it's a problem for everybody, and it is already now. I mean, honestly, the climate change is already happening now, and we're seeing the impact.
Welcome to the third podcast in this series of our interview with Professor Reto Knutti, one of the most renowned climate scientists on the planet. This is the place you need to come today to get the hard facts, because that's exactly what we're going to talk about in this podcast. We're not going to talk about opinions and fake news and things that we might think or something that we heard from a mate that we met down the pub last week. No, we're going to talk to a climate scientist who spent his entire career researching into this. And he's going to answer all those questions that you need to win the argument at your next party. He's going to tell us whether the world really is warming up. He's going to tell us how much warmer Switzerland is on average to the rest of the planet. I'm pretty surprised to find out that Switzerland's warming up much quicker than other parts of the planet. What we're also going to talk about is whether these levels of carbon have ever been seen in history before. We're going to go back in time, thousands and millions of years, to find out when was the last time that we had this much carbon in the atmosphere, and also how quickly it's rising at the moment. The unprecedented rate of change is something that we're going to talk a lot about in this podcast. I do hope you enjoy it. Keep listening so you have all the facts you need to form your own opinion about climate change. I mean, let's just start off, before we all run off and get busy. Is it true? How can you tell us that it's definitely true? Because there's a lot of people out there that are claiming it's not, right?
Obviously it's true, but that's not enough for you. I guess we're at the point where actually few people would still say nothing is happening. I mean, you can go out and measure it. You can measure from the deepest ocean up to the stratosphere, from Antarctica to the Arctic. I mean, everywhere where you measure, you see changes that are large in amplitude, and they're fast. Right? In a historic context, there's a lot of things happening now on timescales of a decade or two that are completely unprecedented in thousands of years, sometimes millions of years. We are now at CO2 levels that have not been observed or reconstructed in the atmosphere for millions of years. And actually humans only exist for like 200,000 years or so. So we have to go very, very, very far back to see similar changes. Obviously, climate has changed before, because that's what people always claim, and that's true, right? Continents have moved, and the sun has changed, the Earth's orbit around the sun has changed, volcanoes, and there's lots of things that can make climate change over various timescales. But what we're seeing now is much faster, it's much stronger, and it has a different cause. It's the emissions of greenhouse gases, mostly CO2, methane, N2O, and a bit of cooling of aerosols. So that's the observations part. Then we know, of course, from theory, and we've known for more than 100 years, right? Before 1900, the physicists were doing spectroscopy, and they were saying it must get warmer with more CO2, long before it was observed, because we understood the physics of the greenhouse effect, long wave gases being trapped, and so on. And then we have models where we can actually calculate these things, we can quantify these things. You can measure the changes in long wave radiation at the ground, on the satellite. I mean, we're completely beyond that point.
Okay, and so if we talk about long wave radiation, that's basically the thing that warms us up, right? If we talk about, if you stand near a window and you can feel the heat, it's the sun's long wave radiation that's getting through the glass.
It's not the sun, right? The sun is the short wave that's heating up something. And the sun is heating up the surface, and then the Earth's surface has to lose that energy again, and it's losing it in a long wave spectrum. That's essentially heat. That's what you would feel when you stand next to the fireplace. If you're putting more CO2 in the atmosphere, that tends to sort of block the long wave radiation from going out to space. It's like putting another blanket on top of you when you're in bed, and a third blanket and a fourth blanket. And then at some point you're like, oh my God, it's hot. Right? Because you're not able to lose the body energy anymore towards the outer space.
I understand what you mean. That's the reason why when you get into a sleeping bag, it feels really cold, and then you shiver a little bit, and then it warms up because the energy's not leaving the bag, right?
Exactly. That's what's happening. And that's been understood for a very long time. I mean, the first scientific warnings to the US presidents were Lyndon Johnson in the 60s.
65,
right? So in the 60s, people already on a political level said, this is going to be a problem. And
Yeah.
actually, also in Switzerland, there have been reports written by scientists to the government in the 70s, 80s already. It's been known for a very long time. And we've created the Intergovernmental Panel on Climate Change, doing these big assessment reports in '88. So that's already been more than 30 years, right?
Yeah.
Same with the United Framework Convention on Climate Change. We're talking about 30 years of a political process in climate negotiations. Then it's not a new thing. Right?
Yeah.
It's really not a new thing.
And sometimes when you hear about the climate deniers talking, they'll talk about, well, actually, if you go back far enough, there was lots of CO2 in the atmosphere, like, thousands and thousands of years ago. But isn't that because we were like, the planet was just forming? It was before we really even had life. Well, how far do you have to go back to the last time that you got as much carbon as this in the atmosphere?
That statement is true. If you go back several million years, then you get to similar states as today. If you go even further back 100 million years, the dinosaurs, and there were higher concentrations of CO2, but obviously for different reasons. And then at some point, the carbon was stored on the ground as oil and gas, and now we're putting it out again. So yes, climate has changed, but for different reasons and on different timescales than now.
Okay, so what we're basically saying is like the coal and the oil and things, they were a little bit like the OG climate capture. We had a lot of CO2, CO2 capture, the carbon capture, had a lot of CO2 in the atmosphere, then it all went under the ground and everything was fine until about 200 years ago when people invented the locomotive and etc.
In the simplest terms, that's what's happening.
Okay then. All right, so we can definitely prove there's been a big step change with the climate, but the question is now, what can we do about it? Now we're talking about things like tipping points at the moment, but what is a tipping point? Why should we care about tipping points?
I'd like to start before the tipping points, actually.
Okay,
I'd like to start with the things that we understand well. First of all, it's getting warmer.
Yeah.
It's getting drier in many places in summer, especially in the already dry regions. There tends to be more droughts.
Yeah.
We're seeing trends in heavy precipitation, strong rainfalls, and hail and other related properties, which causes damage and floods. Right? And we're seeing changes in the snow and ice, so less snow, glaciers melting, sea level rising, and so on. So these are the things, and we can go into detail if you would like.
No, please do.
Which we understand well. Right? Yeah. And then there are things that are sort of less well understood, and that's what people refer to as tipping points often. These are things that can rapidly change from one state into a different state. So if you take a glass and you push it towards the side of the table, then at some point it falls off and then it breaks. Right? And often you know quite well what the consequences would be. It falls down and it breaks. You don't quite know exactly when it's going to tip over, right? Because the process of tipping is hard. Right?
Okay.
And there's a number of these elements in the climate system. One is the ocean circulation in the Atlantic. It's often referred to as the Gulf Stream, which is not completely correct, but it's sort of the deep circulation in the Atlantic. Then there's the thawing of the permafrost. There's methane hydrates. There's the West Antarctic ice sheet. There's the Amazon rainforest. There's maybe monsoon. So these are systems where we think they have a dynamical behavior that they could switch from one state to something relatively different in a short period of time. Okay. Which actually you could argue puts more pressure on people because there's no time to respond or adapt to.
I see, changes. Because it's going to be a step change.
It's kind of flipping the switch from one.
A little bit like when a storm comes quickly on a lake, and we sail on a lake, and then all of a sudden when you see a cloud in that direction, it's like time to go to harbour kind of thing.
Although I would have, I'm a bit sort of tempted to not put too much emphasis on the tipping points because they tend to be uncertain, right?
Okay.
And from a communication point of view, it's hard to tell someone, look, here's a potentially dangerous thing. It might cause the world to end, but really we don't know.
Okay.
I mean, what do you do with that information? Something that could potentially be completely disastrous, but you have no clue on whether it's going to happen and how to respond to it.
Well, it's good for podcasters. We need drama. We need drama.
It is actually good for drama. No, it is actually good for drama, and you can see the media taking a lot of writing a lot of articles about it because it sounds dramatic, right? But often people are then sort of lost because oh my God, the world is going to end, maybe and maybe not. Right?
Yeah,
Well,
and so we
what
might
do
as well give up anyway, right? Yeah.
So the tendency is to either you ignore it because you say maybe it's not happening, or you're completely hopeless because you think the world is going to end anyway, right? But there are a lot of changes that we do understand well. So if it's getting drier, we have to make sure that we have enough water and we plant the right crops and so on. So there's a lot of things where we understand well and we know how to respond to them.
And there are many wonderful examples of people who've really basically reforested deserts. Basically, they've gone out, they've dug holes. They've waited for the monsoon, rain to come. They've put some kind of seed and some kind of gestation assistance, some kind of manure or whatever inside these holes. And all of a sudden, an area that's been a desert for so long has been greenified, or what would you call it? It's been reforested, I don't know, turned into arable land where you can make crops, right?
Absolutely, there's tons of things you can do on all levels, and in different regions there are different solutions. Some are based on sort of nature aspects, sometimes people call it nature-based. Some are completely technological, and all of these are fine. Right? But I think in the broadest sense, if you want to take it to the root cause, you have to absolutely stop burning fossil fuels.
Okay,
that's going to be the way to stop the Earth of warming. It's not going to reverse it, by the way. We can go into that. And then you have to adapt to the changes because things are already happening. Right? We are already seeing a warming of about 1.5 degrees, maybe 1.4, but we're close to that Paris target of 1.5. Here in Switzerland, we're seeing 2.9 degrees.
Wow.
Twice the warming, and we're seeing the impact. We're seeing them now in every aspect.
And if we don't do anything, if we carry on as we've been living and, let's say there's a general sort of trend with efficiencies, like airlines don't want to burn more fossil fuel, right? The more efficient the aeroplane is, the better it is. We've done a lot of interviews as well with sustainable aviation companies. And of course, the problem with the aviation sector is it's a very large invest. So if you bought a plane in, let's say, 1990, it's only been decommissioned now in 2026. Because it's got a lifespan of 30, 40 years, maybe flying for different airlines during that time. But we need to wait for those new technologies today to actually have an impact in 20 years' time. But assuming that we carry on in this course, that things get a little bit more efficient, but we're not really taking the whole thing seriously, what's going to happen? Is this just a problem for people in the Southern Hemisphere, or is this a problem for Europe? Is it a problem for Canada? Why does everyone move to New Zealand, right?
It's a problem for everybody, and it is already now. I mean, honestly, the climate change is already happening now, and we're seeing the impact. We're maybe not dying from climate change here in this part of the world, but the impacts are real. It hurts people, it hurts agriculture, it hurts tourism. We're seeing the increase in flooding. We're seeing things, right? For a long time, people said if we don't do anything, people sometimes called it business as usual, we would end up at 4 degrees global warming, 5 degrees global warming. I think the business as usual is a bit misleading because we're not going to do the same things over and over again. We're not taking the horse if we go to work in the morning just because there are better alternatives, even without climate policy. Right? But if we make it more specific, the current policy scenario, that's basically what in the laws today of the countries brings us to something like 3 degrees warming globally, which would mean maybe 5 degrees here in Central Europe. If the countries did what they claim they want to do, that's sort of the COP commitments, nationally determined contributions and so on, we would end up with something like about 2 degrees warming, global mean.
Okay.
But the problem is that they're not doing what they're claiming they want to do, right? It's easy to say we will and then not do it, right? Which is still quite a bit more than the 1.5 that we're actually aiming for in the Paris targets.
So I'm going to have a little attack on climate science now. So I do hope you enjoyed that third episode in our series of podcasts with Professor Reto Knutti. Today we talked all about the hard facts of climate change, the stuff that we do know. In episode 4 we're going to be talking about the kind of unpredictable side of climate change. We'll talk about something called non-linearity. We'll talk about the things that we know will go wrong at some point but we're not quite sure when. It's a very fascinating conversation where we're going to talk about things we don't know with a scientist and why we don't know them. So please do subscribe to our YouTube channel, The Earth Circle, then you'll get that 4th episode in your feed. Or otherwise, if you want to see all the episodes today, you can go over to patreon.com. And at patreon.com, if you search for The Earth Circle and register up there, you'll be able to hear all of these interviews today already. They're all waiting for you there. So like I say, next time round, we're going to talk about what will happen if we go beyond the 2 degrees limit. We'll talk about the things that are going to go wrong and why we don't know whether they'll go wrong at 3 degrees, 4 degrees or 5 degrees. It looks likely that we're going to overshoot on that 2 degree limit, and we're going to talk about why we'll also have to wait thousands of years for the world to cool down again, that's unavoidable. What we'll also talk about is the impact on your life. So what kind of vegetables, for instance, will grow in the future? Will we be able to eat potatoes in the future or not? Will we have trees in our garden or not? These are all interesting things. And we'll talk about the societal impact and also what we can do today to change that. So once again, as ever, with Professor Reto Knutti, he's a very pragmatic person who talks about what we can do. He's not a finger pointer. So do tune in next time to hear some more facts that are really going to be maybe giving you a very, very deep insight into what's happening in the world around you and what we can do to change that.